Hello, Naf Ninja here. So today I'm here to talk about isomorphisms.
That's good, yeah.
So 2 weeks ago we talked about bijections, and bijections between two functions, or between two groups, is a way to measure size, same size. And isomorphism will tell us not only same size, but also tell us it says same multiplicative property, same multiplication. So how do I describe isomorphism? It's like saying we have two different fish, right? A sunfish and a flounder, and they swim the same. They swim exactly the same. That's what isomorphism says. The groups, their multiplications look exactly the same. So, but we can have groups that are not isomorphic. For example, a sunfish does not move like a starfish. So, two different things. So isomorphism tells us same size, and also because it's a bijection, it's a function of the bijection. And also tells us same multiplicative property, same multiplication table. So really, it's just giving us saying that one group is really another group in disguise. So just a shout out, last week you guys had a test. James Burdick, very good. You re-derived the dyadic rationals independently and prove that all subgroups of the rationals need not to be cyclic. And the counterexample I used was a over 2b, the rational where b is a natural number and a is an integer. Good job. So, okay. So, in the book, they talk about the chessboard. In chessboard, they show that it's isomorphic to some dihedral group or something like that, or multiplication modulo group. I do not have chessboard. So instead, I will be lazy and do what the Asian people do best. Write out multiplication tables. So we shall do that. So multiplication table, I'm going to show you that the four numbers of C4, 1, -1, I, and -I is isomorphic to the addition modulo 4. So let's write out the table. 1, -1, 1, -1, -1. Let's change colors. So, okay. So now let's look at addition modulo 4. So addition modulo 4, we have so we have the elements 0, 1, 2, and 3, right? But just for fun, I'm going to mix it up a little and say, let's look at 0 to 1, 3. Yeah, 0 to 1, 0 to 1, 3. Okay, additional modulo 4.
also makes us make things look even more somehow. You can do that too. Yeah. That's cool.
Okay. So notice, all the ones, the same color, are the same positions as the zeros. The negative ones, same positions as the twos. The negative i's are in the same position as the threes. And the negative ones here are same position as the twos, and ones, same position as the zeros. So really, this is just, Z4 is really the complex multiplication group in disguise. So we call this isomorphism. If we can just say one group is really disguised with the other group. If we can find a mapping of one group, so it looks like this other group of multiplication table. So rigorously, we say something's a bijection if, or something is isomorphism if two things are connected. So definitely. And isomorphism,
it also screws up something. These are all separate things.
between
When you keep them separate, it doesn't matter to it.
groups G1 star 1 and G2 star 2 is a mapping phi is a mapping like phi such that 1 is a bijection.
See, now I'm just saying my time.
1 maps to G1 and G2 is a bijection. So in other words, I want one green to map to only this green and not turn anything else green. Same color pattern. And secondly, I want everything here to be mapped from anything here. So everything has a color. So it has to be a bijection. And 2, I want the same multiplication table, same multiplication property. So when I take the multiplication, when I take two things in the first group, x1 times x2. This is first multiplication. When I map it under my function phi, I just want to equal something mapped, multiplication x1 mapped, multiplied the second by x2. The multiplication in here corresponds same value as the multiplication. We take them separately in here. That's the intuition behind statement number 2. We call statement number 2 homomorphism. So an isomorphism is a bijection that is a function such as a bijection and a homomorphism between two groups. And if there exists an isomorphism between two groups, we write for the following symbol. What's the symbol? It is, how do we